Okay, last part of section 8.9, we're going to work example 8.3 and 8.4. The problem as it looks, and I've got a drawing here I'll share with you. Okay, the problem says I have a three-phase 60 hertz generator, three-phase 60 hertz generator, and the line-to-line voltage, or another way to say that is the phase-to-phase voltage, is 23,900 volts. Now, where does that come from? Well, that is actually a common voltage used in electrical power transmission, generation, and distribution. And so that number is sort of a standard number. It's just not pulled out of the air. And so what he's saying is that the line-to-line voltage, our phase voltage, is 23,900 volts. And what I'd like to know is, what is the line to neutral voltage? Okay, I've got this equation 8.4 that we came up with in the earlier section. I'm going to solve that for ELN. And so ELN is going to be equal to E line divided by square root of 3. And what I will come up with is 23,900 divided by 1.73, our exact value, which is square root of 3. And I come up with 13,800 volts. That would be the voltage that I would read from here to here. If this would be line to neutral, 13,800, that would be the voltage from phase to neutral if the line voltage or phase to phase voltage was 23,900. Okay, the second thing says, what is the voltage induced in the individual windings? What is the voltage induced in the individual windings? Well, what we're talking about when we say the individual windings, we're talking about winding here, and then winding here, and then winding here. Okay, so what we would find out is that the voltage, this is symmetrical and everything else is equal. So the voltage induced in each of those would all be equal to the same voltage that we found in the one that we solved for. Okay, so they'd all be 13,800. The next one says, what is the time interval between the positive peak of phase A and the positive peak of phase B? Okay, so a little thought process here. Let's think through this for just a second. So if something is occurring at 60 hertz, well, that would tell us that one cycle at 60 hertz would be 1/60 or 1/60th of a second. So if I wanted to know what portion 120 degrees is of one cycle, I could just say 120 over 36 times that time of one cycle. And, you can see that this is going to be, basically a third of that, right? So working that out, I end up with 1/180 seconds. And that comes out to be 5.55 milliseconds, the time for that peak to occur. And then the last thing, it says, what is the peak line voltage? Okay, the only reason we're really going through this is, just to understand that, okay, our maximum voltage, is that the line voltage is 23,900. That's a sinusoidal voltage, right? And all these are given to us as effective or RMS values. If I want to know the peak value of that, I multiply by the square root of 2, or 1.414 times 23.9, and a peak value of 33,800 volts. would be the number that I'm looking at there. Okay, very good. All right, so what we're saying is the peak or phase-to-phase voltage is always the square root of 3 times the line to neutral voltage.